Hello guys, and welcome back to this channel. In today's video I'm going to talk about the kidney ability to regulate the amount of blood that gets inside the glomerulus. Before we talk about the two main mechanisms that auto-regulate the amount of blood getting to the glomerulus through the kidney, we need to first talk about the mechanism that happen inside the afferent versus afferent arteriole to regulate all this amount of blood. So the afferent, starting with A as an apple, afferent arteriole is the arteriole that brings the blood inside the glomerulus, and the efferent is the E, with the E as an elephant, is the arteriole that is responsible to drain the blood back into the peritubular capillary. So it takes the blood out of the glomerulus and it drains it into the peritubular capillary around the nephrons. So these two arterioles are going to act synergically to either increase or decrease the amount of blood coming in the kidneys. So if the afferent with A increases his diameter, meaning vasodilating, while the efferent, the living arteriole, vasoconstrict, we're going to have an increase in the GFR, increase in the amount of blood going into the glomerulus. But if the afferent, A for apple, vasoconstrict, and the afferent, E for elephant, vasodilate, we're going to have more blood leaving and less blood getting into the capillary of the glomerulus. So these are the two main mechanisms I wanted first to talk about before we get into the auto regulation of the kidney flow. So the first auto-regulation I want to talk about is called the myogenic reflex. It's just a fancy word just to say that the muscle in the afferent, A as an apple, the muscle in the afferent arteriole is a smooth muscle. It's able to contract due to the stretch. So if you have a huge amount of blood, maybe you have an increased blood pressure coming from your aorta, and when it reaches this A as an apple arteriole going inside the glomerulus, that arteriole is going to stretch, and the response to that stretch is going to constrict to limit the amount of blood getting into the glomerulus. So that is the main arteriole that acts when you have that high amount of blood. And if you have less amount of blood getting into the kidneys, the arteriole is going to vasodilate, so more blood gets into the glomerulus. So this is how the myogenic reflex is done. Now we also have another reflex that is called the tubuloglomerular feedback reflex. So meaning tubuloglomerular, it has to do with the tubule in the nephron and the glomerulus as well. So inside our nephron, we have a zone that is called the juxtaglomerular apparatus. It forms like a little triangle coming from the afferent arteriole, glomerulus, and the distal contorn tubule. So it's a little zone right there, and we have multiple cells there. And the main cell I want to talk about is the macular denser cell. So this macular denser cell, they are located in the portion of the distal contorn tube that approximate that little triangle that I just talked about. And these cells are responsible of sensing sodium chloride. So once they sense a huge amount of sodium, which can be happening if you have an increase in your glomerular filtration rate and the proximal tubule don't have enough time to reabsorb all that sodium. So the macular denser cell can sense that increase in the sodium, and what it's going to do is going to do everything to decrease your glomerular filtration rate. So how does it do to decrease your glomerular filtration rate? So it's going to increase the release of adenosine. So adenosine is a molecule that is going to act both on the A as an apple, afferent arteriole, and also on the efferent arteriole, but are two distinct receptors to do completely opposite action. So adenosine, released by the macular denser cell, is gonna act on the afferent as an apple arteriole on the receptor A1A, and these receptors are gonna be responsible. Remember, we have an increase in glomerular flow. Now we need a decrease in glomerular flow. So they're going to vasoconstrict that afferent arteriole. And then the same adenosine is going to act on the efferent arteriole on the receptor 1,2B to dilate that efferent arteriole. So we're going to have a decrease in our glomerular filtration rate because of the high sense of sodium chloride by the macular denser cells. So, and also, if we have in the same alignment, if you have, like, let's say a decrease in your glomerular filtration rate, so if the macular denser cell sense less sodium, they're gonna activate more renin, and the renin is gonna be responsible of increasing the reabsorption of sodium and water. And I just want to make sure that we all know that renin is secreted by the juxtaglomerular cell, also called granular cell. These cells are, like the name says, juxtaglomerular, located beside the macular denser cell at that little triangle junction that we talked about. So macular denser cells are going to increase the release of renin by those cells. Renin is going to be responsible of increasing the absorption of sodium and water, which follow along. And it's also going to secrete nitric oxide and prostaglandin I2, which are potent vasodilator to vasodilate the afferent arteriole. So we're going to have an increase in our glomerular filtration rate. So these two main mechanisms auto-regulate the amount of blood that gets into the glomerulus to get filtered. And if you like this video, please thumbs up, share, and subscribe, and I will see you on my next video.